Hey, so we're into chapter 7. So what this chapter is going to be talking about is what makes a good survey and how do we interpret our results. So before we get started, a lot of the times we ask a really big question that asks about way too big of a population. So what that means is that we can't observe every single person we want to, so what we have to do is take a subset or a sample and then answer a question about that. So first, we have to look at some vocabulary. So a population is a group of objects or people we wish to study. So for example, if we want to look at heights of US males 18 to 60, okay, then what our population would be is the group of objects or people. So we want to look at these people. We want to look at US males. Now the parameter is the numerical value that characterizes some aspect of this population. So if we are interested in the heights of US males, then our parameter for this example, let's say that we want to look at average height of US males. Okay, so in this case, the parameter is, hey, what is the characteristic or the numerical thing that you're interested in? Now, a sample is a collection of people or objects taken from the population of interest. So it's impossible for us to get the height of every single US male between the ages of 18 to 60. So instead, we would look at a sample. So we would say that we took a collection of OC male students. So we didn't look at all US males, but what we did is we just looked at everyone at OC. And then the statistic, or also known as the estimator, is what we saw when we looked at that sample. So we would say that OC males have an average height of, let's say that they have an average height of 5 foot, well, let's say 5'8". So that would be our statistic, and OC males would be our sample. Now, sometimes what you can do is that you can get every single member of your population that you're interested in. So let's say that I'm only interested in the average height of living relatives in my family. That would not be that hard to get the height of everybody and take the average. So when we get every single member of our population, that's called the census. So for example, you can think of every keystroke on a computer. That would be a census. That's something that we can easily record. Okay. So let's look at an example of defining these things. So today I made up a fake study, and in my fake study I wanted to study the entire mouse population of Washington State and decide what percentage of mice were males and females. I safely collected 15,433 mice and released them back into the wild unharmed. The survey found that 48% of the mice were male. So, if I'm going to identify the population, who was I interested in? Well, I was interested in the mouse population of Washington. Now, I couldn't get every single mouse in Washington, but what I did get is I collected 15,433 mice. Now the parameter, what was I interested in? Well, when I read this, I'm interested in the percentage of male mice. Remember, if I know the percentage of male mice, I can determine the percentage of female. Now the statistic, which is what I found, is I found that 48% of my sample were male mice. So remember, I was interested in all of the mice in Washington, which I'm not even going to try to draw Washington Okay, but I was interested in all the mice of Washington. But what I found is that stop going crazy. I found that a little subset, which was 15,433 of them, and I found that 48% of them were actually male mice. Now, let's say in the state of Washington, man, I have no idea how many mice there might be. Let's say in the state of Washington there's actually 2 million mice, and let's say that 51% of them are male. Okay? That's the difference between a population and a sample, and the difference between a parameter and a statistic. Okay, now here's the big difference between a parameter and a statistic, is that a parameter belongs to the population, while a statistic belongs to the sample. Another big thing that you guys need to know is that these are typically unknown. These are things that we're trying to explore, while statistics and samples, we know those because we have observed them. So to differentiate between whether we're talking about a statistic or a parameter, we use different notation. So if we're talking about a sample average, we use x bar. If we're talking about the sample standard deviation, we use S. Sample variance, we're not going to cover that in that class, so don't worry about that. And if we're talking about a sample proportion, that's a percentage, we use p hat. I know this sounds silly, but the way that I remember that these go with samples is I think if you're leaving your house to participate in a survey, you have to get fancy, so you have to put a hat on. I don't know, that's just what I think. Now if we're talking about a population, we're talking about a population average, we use mu. Population standard deviation, we use sigma. Again, we're not going to be looking at variance in this class, so don't worry about it. And population proportion, we use p. So, in the example up above, p hat would be 44% and 51% would be p. So, x bar equals mu and p hat is going to equal p if we have a census. Now here's the thing, how do we use mu, sigma, sigma squared, and p if we don't know what they are? What we do is that we use computers and stats to estimate them using the statistics we do have. So in the last example, what we would say is we would say, oh, well, we don't know that the Washington population is 51% mice, but we could say, hey, our sample leads